Hi then, what's up you guys? I just want to welcome you right here for this mathematics lesson. Well, my name is Mr. Joel, your tutor for this lesson. Alright guys, so let's take a look at what we're going to be learning in this lesson. Joint variation. In this lesson, you will be learning about joint variation. A combination of the knowledge obtained regarding direct and inverse variation will be used. Alright, so we are at this chapter which is called variation. So remember that we have learned two types of variations. Direct variation involving two quantities and also inverse variation involving two quantities as well. Now, when we put both of them together, we have one combined variation which is called joint variation. Alright, now let's go through again those two variations which we have learned previously. Direct variation, we have learned that a direct variation of y equals to kx means when quantity x increases, quantity y also increases and vice versa. If we were to plot the graph of a direct variation, it will look like there. Alright, so this guys is the graph of a direct variation involving y and x. So take a look at the equation, and when we put it in equation form, we get the equation y equals to kx, where k is the constant of variation. So when x increases, y will increase. That is called direct variation, and vice versa. Alright, what about inverse variation? A bit of revision right here. An inverse variation of y equals to k over x means when quantity x decreases, the quantity of y increases. It also works in the opposite way. When quantity x increases, quantity y decreases. Alright, let's go on. The graph of y equals to k over x can exist in two forms. Alright, what are the two forms? Let's check them out. The first form is when y is plotted against x, you'll get a reciprocal graph. Or when y is plotted against 1 over x, you'll get a straight line. Alright, so these are just the properties of these two kinds of variations. Remember guys that they are actually a total opposite of each other. The inverse variation is very unique because when one quantity goes up, the other goes down and vice versa, alright? So remember that you need to identify and understand both of these variations before we go into the content of this lesson, alright? So that is what we're going to be looking at right now. Joint variation, alright? What is it? So I bet you guys now have quite a clear picture about what it takes, right? But now let's examine it closely. Joint variation is simply combining the ideas above. Let's take for example, when you are driving, the speed of the car is related by the distance traveled and the time taken to complete the journey. Alright, so we can apply it to specific instances in our daily lives, alright? Take driving for example, right? What are the quantities involved when you take speed for example? Distance is also involved, right? Time is also involved. Now, take a look at this. The relation between speed and distance. When speed increases, more distance is covered, right? And hence, we get a direct variation, which means and can be represented with speed varies directly with distance. Alright, so the faster you go, remember, distance will actually increase as well. Alright, you can actually cover more, alright, distance in the same time as if you were to drive at a slower speed. So remember, this is actually an example of direct variation. But now, let's consider the relation between speed and time. Take a look at how they are actually connected. When speed increases, time decreases. This is where we have an inverse variation, and when we represent it using the variation form, speed varies as 1 over time, which is the inverse variation relating speed and time. So same thing, guys, when you actually drive faster, right, or when your mom or dad actually drives faster, less time is needed, right, to come to school. But always remember, follow the speed limit, okay? So this is just an illustration of what are the quantities involved. So now, when we put both of these variations together for this example, this is what we get. Speed varies directly with distance. Speed varies inversely as time. Therefore, look at the arrow, speed is equals to distance over time, because we can actually combine both these variations together and it can be represented in just one joint variation. Okay, so the positions are still the same, distance is on top, time is below. Alright, okay, so guys, that is just an example of joint variation in our daily lives. Alright, so as you have probably noticed, indirect and inverse variation, it involves two quantities, but joint variation now involves three quantities. Alright, now let's check out another example where you can find joint variation. Take a look at this one. Another example of joint variation is applied in physics. V equals to IR. In this case, V equals to the voltage, I equals to current, and R equals resistance. In mathematical form, we say V varies directly with I and V varies directly with R, or V varies directly as I and R. Joint variation involves three variables. Alright, so this, guys, is another example where you can find joint variation. In the physics formula or science formula, V equals to IR. So notice that there are actually three, alright, quantities involved: voltage, current, resistance. Alright, and because we have two joint, alright, and we have two direct variations, we can combine them to form a joint variation. Alright, so now, guys, we know that a joint variation always involves three quantities. Alright, so that is one thing you guys must remember. Alright, how many types and how many possible combinations are there when we combine direct and inverse variations to form a joint variation? Let's take a look at the general forms of joint variations. Take a look at this table. Alright, so we have three relations and they are symbol form and equation form. Okay, I'm going to bring you one by one, alright, through these relations. Take a look at the first relation. Follow me, alright? Y varies directly as x and z squared. Now, there are actually two direct variations here. When we actually put it in symbol form, it is y varies as xz squared. And when we convert it to equation form, it will become y equals to kxz squared. Alright, so these are actually two direct variations combined. So the first possible type of joint variation is made up of two direct variations. Alright, next relation. Y varies inversely as x squared and z cubed. Now take a look carefully at the structure of the sentence. Inversely as x squared and z cubed. So it is actually made up of two inverse variations. How do we write them? In symbol form, y varies as 1 over x squared z cubed. So we put both of them together. I'll show you guys later on, alright, in some examples. And equation form, y equals to k over x squared z cubed. Alright, and the final possible form of a joint variation, we have an example here. Y varies directly as square root of x and inversely as z. So as you have probably noticed right here, there are actually two variations. One direct, one inverse. So in symbol form, it will be y varies as square root x over z. Equation form, y equals to k square root x over z. So guys, it is just pretty simple to remember, alright? Remember, there are only three general forms of joint variations, alright? It can be made up of two direct variations, two inverse variations, or one direct and one inverse variation. These are the three possible combinations of any two variations, whether they are direct or inverse to form a joint variation. So guys, at the start of this lesson, we mentioned that a joint variation always involves three quantities. There they are, alright? So just bear in mind what kind of variations are involved, alright, to form that joint variation. Alright, one very important reminder. When solving questions, don't forget to include a constant k into the equation. Alright, so this is just a reminder for all of us, alright? When you actually solve questions like we did, alright, indirect variation alone, inverse variation alone, don't forget to put the k, alright, the constant of variation, because it belongs to the equation no matter what the variation is. Alright, so with that now, let's go on to our first example by taking a look at a few relationships. State the relationship of each of the following variations using the symbol, the variation symbol. Alright, so A, W is inversely proportional to X and Y. B, M varies directly as N and P square. C, A varies directly as B and inversely as square root of D. Alright, now let me just show you and guide you, alright, and how to actually write, okay, something, a joint variation given in descriptive words or text, alright, using the variation symbol. Come, let's do it on the board. Alright guys, so let's take a look at the first one and let's go directly to this one. Okay, so W is inversely proportional to X and Y. Alright, taking a look at this whole sentence, how many quantities do you see? I see three. W, one of them, X the second, and Y the third. Okay, now, definitely when three quantities are involved, joint variation occurs. But what is the general form of this? Inversely proportional to X and Y, which means that we have actually two inverse variations. First one, W varies inversely as X. So I'm going to write that separately first. So W varies inversely as X. Remember, 1 over X. And at the same time, W is also inversely proportional to Y. So we have another one, which is W varies as 1 over Y, right? So these are actually the two variations involved. Both of them are inverse. Okay, now just take a look at how do we write them, because it is not enough when we have two separate variations. Let's combine them. Alright, and when you combine them, guys, it is very simple. Okay, so it will be W varies inversely as X and Y. So W, we can write it, variation symbol, 1 over X, 1 over Y, just put the X and Y together at the bottom, and there you go. Okay, so this represents a joint variation involving W, X and Y. So take a look at the two separate variations, combine them to form a joint variation, but their positions are all always intact. Okay, now let's go on to the second one, alright, and let's examine what are the quantities first. M varies directly, alright? When you see words like that, guys, don't forget to always highlight them, alright? Or underline them, okay? Because we know direct variation is involved. So M varies directly as N and P square. So again, we have three quantities here. And definitely because there is direct variation, so therefore, from the structure of the sentence, M varies directly as S, M varies directly as P square. So there are two direct variations. So how do we write a joint variation involving three of them? First of all, let's write them separately first. So M varies directly as N. Okay, that is one of them. So that's all. And the second one, M varies directly as P square. Right? So we have learned how to do this. Now, when we combine them, don't forget you have to just combine them together. So M will vary directly as N and P square. Because both are direct variation, just write them together. Okay, so there you go. You have a joint variation. Okay, now we have the third type, which is a combination of one direct variation, where in this example, A varies directly as B. Okay, stop there. directly as B. Okay, so I'm going to write it first, all right, because it is a combination. So A varies directly as B. What about the second variation? N inversely as D. So notice that there are two different variations there as compared to the earlier ones. All right, the earlier ones are just combination of the same type of variation. So A varies directly as B. We already wrote it down. Next, A varies inversely as square root of D. So A varies inversely. You must always put 1 over square root of D. Okay, now how do we put them together in one joint variation? Very interesting. So A is the title. So A variation symbol comes in right here. Okay, direct variation will always go to the top. Inverse variation will always go to the bottom. So that is how you write them, okay? It is just combining them together. So these are just the 3 possible cases that can occur when you combine any 2 variations. Alright guys, so that is how you express a joint variation. Note that the variation symbol, which looks like a fish, is always there, alright, no matter what kind of variation is being used. Now let's take a look at the next example where we will actually take a look at some calculations. It is given that M varies inversely as N and P. If M equals to 1 over 12 when N is equals to 3 and P equals negative 8. Find the value of M when N equals negative 5 and P equals to 4. Okay, so this is an example of a question where joint variation is involved. Now, how do we do it? Okay, so read this question again by yourself right now. Okay, so I try to get a rough idea of what it is. Alright, wanting you to find out, and let me just guide you through this one and you try it out by yourself later on. Okay, so let's go to the board again. Alright, so guys, remember when you see a question, always try to extract the important parts, alright, and actually write them down. So take a look at this question. I've already written down the main parts, alright, and this is the most important part. M varies inversely as N and P, alright, this is very, very important because they mention inversely, which means inverse variation is happening, okay, as N and P. So since we have 3 quantities, M, N, and P. M varies inversely as N and P. So what do we have here? How many variations? What kind? There are 2 inverse variations. Firstly, M varies inversely as N. Secondly, M varies inversely as P. So, before we can actually solve the question, we must actually write that down first, alright? Because it is not given to us. So, M varies inversely as N and P. Using the method just now, it is, when you combine them, it will be like that. So M varies as 1 over NP because it is varies as 1 over N, varies as 1 over P, and when you combine them, that is what you get. Okay, so before we can solve and find values of variables, we must always find the constant of variation first. So once you have got this, which is the first step, secondly, change it into an equation form, but remember that there will be a constant of variation involved. Alright, so that is what you have to do. Next, this given set of values are given to you when M is 1 over 12. So put it right there. Okay, what is N? N is 3. And what is P? Negative 8. Okay, so it is given to you for you to find out what is the value of K, which is the constant of variation. Alright, so now we can actually cross multiply that up. So we will get that K is equals to negative 24 multiplied by 1 over 12, and our value of K is actually negative 2. Alright, with that now you can put it back inside what you call as the equation involving the 3 quantities. Okay, you need to always put it back. Alright, so what we get is now M is equals to negative 2 over NP. Okay, and this, guys, is very important because once this is in place, we can use it to find other variables. Alright, so same thing like the previous variations. Firstly, write down the relation, change it to equation with a k in it, sub the given set of values to find k, insert it back in the equation so your equation becomes complete. Okay, now we can go on with the question, which is finding m when n is -5 and when p is 4. Okay, so when we actually sub the values in, we can find m. Okay, because now when n takes -5 and when p takes 4, we get that m is -2 over -20, and our value of m is actually 1 over 10. So this question always comes out, alright? So remember the steps that you need to do in order to find the values of variables. Alright guys, let's go on to the next example. It is given that k varies as r to the power of a over n to the power of b, and k varies directly as the square root of r and inversely as the cube of n. State the values of a and of b. Okay, so how do we do this question? Okay, take a look again at this question. It is definitely a joint variation because we can see that there are actually three quantities involved: k, r to the power of a, n to the power of b. So how do we actually do it? Alright, it's a very simple question, but all you have to do is realize that it's actually joint variation involved. So let me just show you this one. Okay, so this is actually given to you from the start. Alright, so you can notice that k is one of them, okay? One of the quantities, alright? Do not mistake this k as the constant of variation because it is not in this case. And we have another two quantities and the variation symbol is right here. Now, we have to find the missing values of a and of b. How do we do it? Alright, from the given information. The given information tells us, okay, so we have to do this separately now. It tells us that k varies directly as the square root of r. We know that the square root of r is like this, okay? Or you can write the whole thing as, and when you have square root of r, it means r is also having a power of half. And at the same time, it also tells us that k varies inversely as the cube of n. So we know it is like this, right? So these are the two indices. Now, when you put both of them together, what will you get? You will get, and when you put both of them together, you will put it right here. The direct variation goes on top, and the inverse variation goes below. So I want you to now compare this whole thing with this form. And by taking a look and comparing, A is half, right? And B is 3. So this is a simple comparison question. Therefore, A is half, B is 3. Alright, so same thing goes. Remember guys, if you can't actually put them together at the first, alright, try putting them separately first, okay? The first variation, the direct one, the second one, the inverse one, and when you combine them to find the joint one, and then you compare, alright, with the given ones, okay? So a lot of questions can be solved by comparing. Alright, now it's time for you guys to try out a few questions, alright? So let me just read out to you some questions, and I want you to try to get the answer for this one. Given that h varies, alright, directly as m squared and l cubed, and h equals to 4 over 9 when m equals to 1 over 3 and l equals to 2. Find the value of l when h equals negative 32 and m equals to 1. Is it A, 4, B, 2, C, negative 4, or D, negative 2? Alright, so we'll be back with the answer in a very short while. Alright, so now let's take a look at what the answer is, alright, and the answer is C, negative 4. So how do you actually come to C? the same steps. Alright, so remember the pattern of questions is always the same. Always go through the steps, get the constant of variation, and put it back in the equation before getting the missing variable. Alright, so let us go through one more question. Alright, so take a look at this example. It is given that y varies directly as x and inversely as z. If y equals negative 3 over 4 when x equals to 2 and z equals to 8, find the value of x when y equals 4.5 and z equals negative 2. Okay, so let me just do this together with you, alright? In case you still can't really get it, it's alright. Let me just show you on the board. Okay, so 3 quantities, 1 direct, 1 inverse variation. So immediately put it in variation form like this. Okay, y varies directly as x, so the x goes on top, and inversely as z, so z goes to the bottom. We have already combined the 2 variations. And notice that we are given a set of values, and this set of values, guys, what do you think is the purpose? This one. It is actually to find k. Okay, and once you have gotten that, you can find x when y equals to 4.5 and z equals negative 2. So it's actually a 3-part or 3-structure kind of question, alright? It is involving 3 parts. So you have to go through it very systematically, alright? So firstly, let us find k first, because we can't find x unless we know the complete equation. So when this is already gotten, change it, alright, to equation form, and remember the reminder at the start, don't forget k, it always comes in right there. Alright, now let's place all these 3 values in. So when y is negative 3 over 4, we get our x as 2 and our z as 8. So I'm just putting in everything directly there. So what will we get is basically, let's cross multiply, negative 24 equals to 8k, and k equals negative 3. So when k is negative 3, where do you put it? Always remember, put it back inside this equation. Therefore, y is equals to negative 3x over z. Because now we already know the complete equation, we can use it to find any variable given the other 2 variables' values. And that is exactly what we have right here. So take a look at this set now. When y is 4.5 and when z is negative 2, find x. So use this now. So when y is 4.5, alright, and z is negative 2, what is x? So put them in directly. Let's cross multiply, and very simple, we have already got the value of x, which is 3. Okay, so that is how you actually attempt these questions. Remember, you must always complete the equation first. Alright, so it's time for you to try out one more question. Alright, so I want you to try this by yourself. Take a look at this example. The table below shows some values of variables p, q, and r such that p varies directly as the square of q and inversely as r. Take a look at this table. P, Q, R. In the second column, we have 3 values. And in the third column, we have 2 of the values and a value n. Calculate the value of n. Is it A, 25, B, 20, C, 15, or D, 5? Alright guys, so remember the same step occurs. You need to actually use just a hint for you guys, alright? The second column where all the values are given is an indication that you must find K, the constant of variation. So why don't you guys try it for a moment? Alright, so let's take a look at the answer. Alright, what is your answer, guys? Let us compare. You should get D as your value of n, which is 5. Okay, so remember to go through all those steps again until you clearly understand. Alright, so before we end this lesson, let's take a look, alright, at a quick review of what we've managed to learn in this lesson. Firstly, write the relationship between three variables in equation form. Secondly, understand that a joint variation refers to the relation between three or more variables such that a variable varies directly and or varies indirectly as the other variables. Thirdly, identify the three types of joint variations, and lastly, solve problems involving joint variations. So alright guys, that pretty much summarizes up what we have learned in this lesson. Alright, so I hope you guys have a good time in your practice. I'll see you in the next lesson.